Dear students, in the last session of previous class, we discussed the Cauchy sequence of logarithms, Cauchy sequence of log n. Check whether log n is a Cauchy sequence or not. So we see that log n is not a Cauchy sequence. What about minus 1 power n? Consider sequence x equals sequence minus 1 power. Check whether minus 1 power n is a Cauchy sequence or not. So for choose epsilon equals 1 by 2. Epsilon equals 1 by 2. Let xn sequence xn x equals sequence xn equals minus 1 power n. So what about xn plus 2? Xn plus 2 minus 1 power all power n plus 2. So xn plus 2 minus xn. Xn plus 2 minus xn equals minus 1 power all power n plus 2 minus 1 power all power n. So this is always 0. Sure. Minus 1 power n plus 2 when n equals 1. So x3 minus x1. What is x3 minus x1? Minus 1 power n equals 1. Minus 1 whole cube. Minus of minus 1. Minus 1 plus 1 equals 0 itself. So xn plus 2 minus xn equals always 0. Now what? Xn plus 1 minus xn. Xn plus 1 minus xn equals minus 1 power n plus 1 minus 1 power n. So that equals minus 1 power n plus 1 into minus 1 power n plus 1 is commonly taken outside. So into 1 plus 1 equals 2 into minus 1 power n plus 1. Agree. That means that is modulus of xn plus 1 minus xn equals modulus of 2 into minus 1 power n plus 1. That equals 2. So modulus of xn plus 1 minus xn equals 2. That means there does not exist a k-fold in n such that modulus of xn minus xm when n greater than m. So xn minus xm does not less than epsilon 1 by 2. There does not exist a k-fold in n such that modulus of xn minus xm less than 1 by 2. 1 by 2 means epsilon. That is epsilon for all n comma m greater than or equals this particular stage capital K, or particular stage k fold in n. So clearly sequence minus 1 power n is not a Cauchy sequence. Agreed. So we see that log n is not a Cauchy sequence. Again, by using this arguments, minus 1 power n is also not a Cauchy sequence. Agreed. Now, now we show this. A monotone bounded sequence. A bounded monotone increasing sequence is a Cauchy sequence. That's the theorem. A monotone bounded monotone increasing sequence is a Cauchy sequence. A bounded monotone increasing sequence is a Cauchy sequence. How? So for let secant xn be a bounded monotone Cauchy sequence. Secant xn be a bounded monotone increasing sequence. Now to show that sequence xn is a Cauchy sequence. Since xn is bounded, means it is bounded above, therefore supremum of xn always exists. Agreed? Supremum of xn exists. So let x equals supremum of xn where n fall in n. Let x equals supremum of xn. Let epsilon is positive, then clearly x minus epsilon by 2 strictly less than x. But what is x? X is the supremum of xn. So x minus epsilon by 2 strictly less than x means x minus epsilon by 2 is not an upper bound. That means x minus epsilon by 2 is not an upper bound. Not an upper bound of the sequence supremum xn for all n fallen n. Thus there exists an element that will be x m naught fallen set of all xn where n fallen n such that x minus epsilon by 2 x minus epsilon by 2 less than x m naught less than x less than or equals x strictly less than x plus epsilon by 2 x minus epsilon by 2 x minus epsilon by 2 less than x m naught less than or equals x strictly less than x plus epsilon by 2. But what is secant xn? But it is given secant xn is monotonically increasing secant. Secant xn is monotonically increasing means so x m naught less than or equals xn for all n greater than or equals m. Okay. That means x minus epsilon by 2 x minus epsilon by 2 strictly less than x m naught. Then what is the next term? Strictly less than x m naught less than or equals xn less than or equals xn strictly less than x plus epsilon by 2. Enough? Okay. That means x minus epsilon by 2 less than xn less than x plus epsilon by 2 for all n greater than or equals this particular stage m or m naught. For all s n greater than or equals m naught. That means modulus of xn minus x strictly less than epsilon by 2 for all n greater than or equals m naught. Okay, for all n greater than or equals 7. Now consider modulus of xn minus xm. So modulus of xn minus xm equals modulus of xn minus x plus x minus xm. By triangular inequality, it is less than or equals modulus of xn minus x plus modulus of x minus xm or xm minus x. But what is modulus of xn minus x less than epsilon by 2? So it is equals strictly less than epsilon by 2 plus epsilon by 2 equals epsilon. That means modulus of xn minus xm strictly less than epsilon for all n comma m greater than or equals a particular stage m naught. That means secant xn is a Cauchy sequence. That is what there gives here. So here we see that when a sequence is monotonically increasing and bounded, then that sequence should be a Cauchy sequence. Means a monotonically increasing bounded sequence is always Cauchy. Agree? In previous class, we said that the sequence 1 plus 1 by 2 plus 1 by 3 plus etc. plus 1 by n, that sequence is not a Cauchy, means that sequence is diverse. Now, let us discuss about a sequence. Consider the sequence 1 plus 1 by 2 factorial plus 1 by 3 factorial plus etc. plus 1 by n factorial. Consider the sequence 1 plus 1 by 2 factorial plus 1 by 3 factorial plus etc. plus 1 by n factorial is Cauchy. How to prove that this one is Cauchy? So, to prove this is Cauchy, you consider for all m comma n falling n with a m greater than n. M greater than n. What is modulus of xm minus xn? For all n falling n, m greater than n. So return xn, secant xn equals 1 plus 1 by 2 factorial plus 1 by 3 factorial plus etc. plus 1 by n factorial. Then modulus of xn minus xn. xn minus xn equals modulus of what is xn? 1 plus 1 by 2 factorial plus etc. plus 1 by m factorial since m greater than n minus of 1 plus 1 by 2 factorial plus etc. plus 1 by n factorial. Agreed? So that equals modulus of since m greater than n, it is modulus of 1 by n plus 1 factorial. Agreed? Plus 1 by n plus 2 factorial plus etc. plus finally 1 by m factorial since m greater than n. Enough? Okay. So this of each quantity in this modulus less than or equals 1 by 2 power n plus 1. So 1 by 2 power, sorry, the first step 1 by n plus 1 factorial less than or equals 1 by 2 power n plus 1. Why? 2 power k always less than, because what is 2 power k? 2 power k always less than k factorial when k greater than or equals 4. Enough? When k greater than 2 power k always less than k factorial when k greater than or equals 4. So therefore 1 by 2 power k is strictly greater than 1 by k factorial means 1 by n plus 1 factorial less than or equals 1 by 2 power n plus 1 plus 1 by 2 n plus 2 factorial less than or equals 1 by 2 power n plus 2 plus etc. plus 1 by 2 power m. Agreed? Okay. That means, now consider this sum. So finally modulus of xn minus xn less than or equals 1 by 2 power n plus 1 plus 1 by 2 power n plus 2 plus etc. plus 1 by 2 power m. This equals 1 by 2 power n into, what remains here? 1 by 2 power n into, from here it is 1 by 2 plus 1 by 2 square, the next time is 1 by 2 cube plus etc. plus 1 by 2 power m minus n. Agreed? Okay. So it is less than or equals 1 by 2 power n into, it is 1 plus 1 by 2 plus 1 by 4 plus 1 by 8 plus etc. for n less than or equals an infinite sequence. That equals 1 by 2 power n into, what about this one? The term inside the bracket is nothing but a geometric series, infinite geometric series with the first term 1 and common ratio 1 by 2, that is strictly less than 1. So the sum is a by 1 minus r. Here a is 1. So 1 by 1 minus r means it is 1 by 2. So that equals 1 minus 1 by 2. So it is 1 by 2. 2 goes to numerator. So it is 1 by 2 power n minus 1. 1 by 2 power n minus 1 strictly less than some epsilon. Agreed? Since n for n is sufficiently large, 1 by 2 power n minus 1 goes to 0. Therefore modulus of xn minus xn strictly less than epsilon. That means secant xn is a Cauchy sequence. So listen, the sequence 1 plus 1 by 2 plus 1 by 3 plus etc. plus 1 by n is a divergent sequence. The sequence 1, so here 1 plus 1 by 2 plus 1 by 3 plus etc. plus 1 by n diverges, but here 1 plus 1 by 2 factorial plus 1 by 3 factorial plus etc. plus 1 by n factorial is nothing but a Cauchy sequence. Okay, right. Now, in previous class, we define a contractive sequence. What is a contractive sequence? Contractive sequence and the constant of contractive sequence. What is contractive sequence? A secant xn is said to, secant xn of real numbers is said to be a contractive sequence if modulus of x n plus 2 minus of modulus of xn plus 2 minus of modulus of xn plus 1, it is less than or equals c into modulus of xn plus 1 minus xn, where c lies in between 0 and 1. If any sequence xn satisfies this condition, that secant is said to be a contractive sequence. Secant xn is said to be contractive sequence when modulus of xn plus 2 minus xn plus 1 less than or equal c into modulus of xn plus 1 minus xn, where c lies in between 0 and 1, and c is said to be the constant of this contractive sequence. Agreed. By using this definition, we try to prove a theorem. Theorem states that every contractive sequence is a Cauchy sequence. Every contractive sequence is a Cauchy sequence. How to prove this one? So, proof is, consider a contractive sequence. Let xn be a contractive sequence. Let sequence xn be a x equals xn be a contractive sequence, means this xn satisfies this condition. Modulus of any c lies in between 0 and 1, modulus of xn plus 2 minus xn plus 1 less than or equal c into modulus of xn plus 1 minus xn for all n fall in n. Agreed? So this is the definition. Xn is the contractive sequence. Now consider modulus of xn plus 2 minus of xn plus 1. So it is less than or equals, by using this definition, it is less than or equals c into modulus of xn plus 1 minus xn. Agreed? So it is again less than or equal c into, what is modulus of xn plus 1 by minus xn? According to this argument, it is again c into modulus of xn minus xn minus 1. Okay? Where this c is again lies in between 0 and 1. This again less than or equal c into what is mod xn minus 1 less than or equals modulus of xn minus 1 minus xn minus 2. Okay. So proceeding like this, what do you get? Finally, it is less than or equals modulus of xn plus 2 minus xn plus 1 less than or equals c cube into modulus of xn minus 1 minus xn minus 2. So proceeding like that, so we have it is less than or equal c power n into modulus of x2 minus x1. Okay. Proceeding in the same line, we have modulus of xn plus 2 minus xn plus 1 less than or equals c power n into modulus of x2 minus x1 for all n following. That is modulus of xn plus 2 minus xn plus 1 less than or equals c power n into modulus of x2 minus x1. Agreed. Now, to prove it is Cauchy, consider for m greater than n, what about modulus of xm minus xn? Now we have to show that to prove it is Cauchy, we have to show that mod xm minus xn strictly less than epsilon for all n, m greater than or equals a particular stage, k for n. Okay. But we have modulus of xm minus xn, it is less than or equals modulus of xm minus xm plus xm minus 1. Agreed. Modulus of xm minus 1 plus modulus of xm minus 1 minus xm minus 2. You can introduce plus or minus. So modulus of xm minus 1 plus modulus of xm minus 1 minus xm minus 2 plus etc. plus modulus of xn plus 1 minus xn. Enough? Okay. You can introduce minus xm minus 1 plus xm minus 1 minus xm minus 2 plus xm minus 2 and so on. So finally mod xm minus xn less than or equals, by using triangular inequality, it is mod xm minus 1 plus mod xm minus 1 minus mod xm minus 2 plus etc. plus modulus of xn plus 1 minus xn. Okay. So by using this argument, modulus of xn plus 2 minus xn plus 1 less than or equals c power n into mod x2 minus x1. So using this, what is mod xn minus 1 there? Xn plus 2 minus xn plus 1 less than or equals c power n into mod x2 minus x1. So here modulus of s, the first term is c power m minus, so the first term less than or equals, first term is c power m minus 2 into modulus of x2 minus x1. Agreed? That is from equation 1. Plus, what is the next term? C power m minus 3 into modulus of x2 minus x1. Okay? Plus etc. plus What about the last term? Cxn plus 1. So it is c power n minus 1 into modulus of x2 minus x1. Enough? Okay. That means modulus of xm minus xn less than or equals, here modulus of x2 minus x1 take outside commonly. What's the means here? It is c power n minus 2 plus c power n minus 3 plus etc. plus c power n minus 1. Agree? Okay. That means it is less than or equals modulus of x2 minus x1 into, take c power n minus 1 commonly outside. What's the means? The term inside the bracket is, here it is 1, the next term is c plus c square plus etc. plus c power n minus 3. Agree? So, one step is skipping. So it is less than or equals mod x2 minus x1 into c power n minus 1 into the sum of these infinite terms. Okay? Infinite terms. Since c lies in between 0 and 1, since c lies in between 0 and 1, we have, come on, c lies in between 0 and 1, limit to c power n is always 0. Okay. Limit of c power n is, since c lies in between 0 and 1, so limit to c power n equals 0. Moreover, mod xm minus xn less than or equals, so here modulus of xm minus xn less than or equals mod x2 minus x1 into c power n minus 1 divided by 1 minus c. From where? So the term inside the bracket is nothing but a geometric series having common ratio c with the first term 1. So c lies in between 0 and 1 means c less than 1. Therefore s infinity is 1 by 1 minus c. So we have modulus of xm minus xn less than or equals mod x2 minus x1 into c power n minus 1 divided by 1 minus c. C power n minus 1 divided by 1 minus c. Now again, so mark it as equation 2. But what is c? C lies in between 0 and 1. Means limit c power n equals 0. Limit c power n equals 0 means modulus of limit c power n equals 0 means limit c power n minus 1. What is limit c power n minus 1? Limit c power n minus 1 is also 0. Agree? Limit c power n minus 1 means 0 means by definition for all epsilon positive there exists k following n such that modulus of c power n minus 1 minus 0, it is strictly less than epsilon. So only for the sake of situation, it is epsilon into 1 minus c by modulus